Recording? Okay. So for lesson 49B, we're going to take two topics that we already talked about and combine them. So bear with me while I draw these pictures here. So we're going to have a line. We're going to have a line. We know that this line is, oh, that's not right. We know that this line is parallel to this line. And then if I cut this transversal right here, okay, so this is, we have two parallel lines that are being cut by a transversal, right? And so remember that we have all of our angles, angle relationships. We have our alternate interior angle theorem, our alternate exterior angle theorem. We have corresponding angles. Okay, so all of these angles are congruent. So that's going to be our piece of information that we need to know. So let me talk about that, just a little refresher. Oh, I forgot one. I forgot vertical angles. Vertical angle theorem. So when I want to talk about this is I know that this angle right here is a vertical angle with this, so these two are congruent. And then these two angles are vertical angles, so those are congruent. Remember, we've got to look for that x when you're dealing with vertical angles. Alternate interior, okay, so I'm inside the parallel lines, but opposite sides of the transversal. So alternate interior angles means that like an angle right here and here, these ones would be congruent, vice versa, inside the parallel lines, but opposite side of the transversal. And then we have alternate exterior, so outside the parallel lines, alternate sides of that transversal. And then corresponding angles means they're in the same relative position, okay? So this angle is in the same relative position as this angle, so those angles would be congruent. So what they want us to do now is we're going to add the level of trigonometry to that, okay? So I'm going to go ahead and I'm going to make a right triangle here. So now I have a right triangle. And I know that this is 153 degrees. This is angle Z. We can see that this is side A, this is side B, this is 7, and that's angle P. And then they're going to ask us to find all of our variables. And so we have to use all of the information that we already know to find our unknowns. So if I'm looking at, let's start with letter Z right here. If I'm trying to find letter Z and this angle 153 degrees, they're supplementary, right? They make this line here. So what I can do is I can just take 180 and find the difference. So I would subtract them and I would find out that Z has a measurement of 27 degrees. Okay, not something really difficult, but I need this 27 degrees, right? Because if I'm looking at my right triangle here, 27 degrees is a corresponding angle with angle P here, okay? So angle P and Z are in corresponding positions, so they're going to be congruent angles. So I can say that angle P has a measurement also of 27 degrees. Now, you don't have to find this angle, but if we're going to use trigonometry, it's nice to have all three of your angles to use. That way you have multiple options for reference angles. So if I'm looking here at this angle, I would just take 90 minus 27 and find out that that angle right there is 63 degrees. Oops, sorry. So this right in here is 63 degrees. Now, if to find A and B, you have a right triangle, so you can use trigonometry. And I would just pick one reference angle, right, to start with. Here I see that 7 is across from that right angle, so the 7 is my hypotenuse side. And if I'm going to deal with this 63 degree angle, that makes side A my opposite. So when I go back here and I write I have my SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if I'm using 63 degrees as my reference angle, that's my theta, I have my opposite side that I'm finding for, and I know my hypotenuse. So if I'm dealing with opposite and hypotenuse, I know that I'm going to be using the sine trig function. So I can type that in as sine of 63 degrees, because remember the angle always goes next to the trig function, equals the side that I'm solving for, a over 7. So now it's just a one-step equation. My variable is being divided by 7, so I would undo that by multiplying both sides by 7. That's going to cancel. Making sure that your calculator is in degrees. If it's in radians, you're going to get wrong answers. So just double check, hit that mode button quick, make sure in that third row down, if degrees is highlighted. I'm just going to hit 7 sine 63, and I'm going to find out that side A has an approximate measurement, and I use that approximation symbol because I'm going to be rounding to the nearest hundredth. So 6 24/100ths. Okay, now we can stick with the 63 degrees to find B, right? So if I'm sticking with my 63-degree angle, but now B is not the opposite and it's not the hypotenuse, so that makes B my adjacent side. So if I'm dealing with the adjacent, I'm finding my adjacent, and I know my hypotenuse. Now I would stick with the hypotenuse because remember we rounded here. We rounded side A, so I would not use side A because of the fact that we're rounding, so it might throw your answer off when you're rounding again. So I would stick with using my hypotenuse. And I'm now going to use cosine, right? Because I'm solving for my adjacent. I know my hypotenuse, so I'm going to use cosine of 63 degrees equals my adjacent side over my hypotenuse. So now I'm going to go ahead and I'm going to solve for my variable. I'm going to undo that division by multiplying both sides by 7. And when I plug that in, 7 cosine 63, closing my parentheses, I'm going to see that side B has a measurement of approximately 3 18/100ths. Now, again, the parallel lines and transversals is not a challenging, but we needed to use that information to find my unknown angle and then take that next step into using the trigonometry. So let's do one more example together. I did make a worksheet for you, only 4 problems, so it's not anything too crazy. I don't think it's going to be relatively that difficult. So I'm going to make my 2 parallel lines here, and then I'm going to make my transversal. And I'm going to remember, whenever you see those little tick symbols like that, those little arrows, that's telling you that my lines are parallel. And you're going to need to know that information when you're trying to solve these things. Let me just fill in my need to knows here. There's my right angle. This is 90. This is N. This is M. And they tell me that this is 158 degrees. All right, so now they want us to find all of my unknowns. So here, let's start with my parallel lines being cut by a transversal. Where's my spotlight? So I know that A and B are corresponding, but I also know they're congruent because they tell me, right? Those little arcs with the tick marks through them, that tells me that A and B are congruent angles. So to find the measurement of angle B, here I have 2 supplementary angles. B plus 158 make this line here. So I'm going to find the difference of 180 and 158. And I'm going to know now that the measure of angle B is 22 degrees. And if angle B is 22 degrees, angle A is 22 degrees. Okay, so here's my theta. Now I have a theta, I have a reference angle. I'm going to use this to find my unknown measurements. 90 is opposite, oh boy, I do that every time. 90 is opposite my right angle, so that 90 is going to be my hypotenuse to my reference angle. A, being the reference angle, makes N my opposite side, which makes M my adjacent side. All right, so here's my trig functions. if I want to solve for m first, okay, so m is my adjacent side. I know my hypotenuse, therefore I'm going to use cosine. So cosine of 22 degrees equals my adjacent side over my hypotenuse. And again, I'm just going to solve for my variable by doing inverse operations here. I'm undoing that division. And when I plug that into my calculator, 90 cosine 22, it's going to give me a measurement. Nope, what am I doing? I don't want cosine. I now know that m is approximately 83 and 45 hundredths. All right, now let's find n. N we said is my opposite side to my reference angle. So if I'm finding my opposite side, I know my hypotenuse. I'm not going to use that adjacent because I rounded down here. I have that approximation symbol. So I'm going to find my opposite side using my hypotenuse, which means I'm going to use my my sine function. So sine of 22 degrees equals my opposite side over my hypotenuse. Again, I'm going to do inverse operations to solve for my variable. That cancels. 90 times sine of 22 degrees is going to give me a measurement of approximately, there's my approximation symbol, so n is approximately 33 and 71 hundredths. Okay, so you'll complete the worksheet and then let me know if you need me.